Okay, so we're going to be graphing sine and cosine functions back from chapter 4. Now, if we remember the unit circle, which I have over here, we can keep going around and around and around. We can do multiple laps around the circle. And so because of that, this graph's going to look a little bit different than other graphs. So here I have my x and y axis. And on my x-axis, instead of graphing 1, 2, 3, 4, I'm going to graph pi over 2, pi, 3 pi over 2, and 2 pi. These are, the four corners, so to speak, about the unit circle. And this x, I'm going to say that this x is actually the theta, the angle values. So here, when theta is 0, it intersects the unit circle at 1, 0. So what is, if I'm graphing y is equal to the sine of x, when x, or theta, when the angle is 0, the sine is 0. So I graph this. So the y is equal to the sine of pi over 2. Well, the sine of pi over 2 is up here, and that's 1. Sine of pi over 2 is 1. The sine of pi, going straight over here, sine of pi is 0. For 3 pi over 2, straight down, so the sine of 3 pi over 2 is negative 1. And then the sine of 2 pi is 0. So this gives this. It's a wave. And it keeps going. So this wave is just going to be copy and pasted a bunch of times in both directions. Just like that. So that's what the graph is going to look like. Now for us, if we just want to graph 0 to 2 pi, this is one period. And so a period is basically how long it's going to take to get back to its original position. The amplitude is from this midpoint to the peak or to the lowest point, the trough. So if you take a physics class, you probably look at waves more closely, but that's all this is. Let's do the same thing, but let's do this for let's do this for a cosine function. So here, y is equal to the cosine of x. So yet again, I'm going to graph my same points. So pi over 2, pi, 3 pi over 2, and 2 pi. Well, thinking about that unit circle, ooh, that's awful. A little bit better. Thinking about the unit circle, right here, when x is 0, when my angle is 0, my cosine value is 1. And then as I go from 1 to 0. The cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Now, a lot of people tend to do this, or they see this and they think, oh, it's a parabola. No. It's a wave, right? So this is going to curve down, and then curve, and then curve back. So just like this. So notice this almost looks a little bit shifted over from here. It looks like we're starting here. So imagine, right, from there to there, that looks like our cosine function. So we want to look at the general form for both of these. So we have y, that's an s. Okay, let's try that again. We're going to have y is equal to a times the sine of bx, and y is equal to a times the cosine of bx. So sine of bx, cosine of bx. So the amplitude, so how high is it going to go? This is equal to the absolute value of a. So, for example, if I have y is equal to 3 times the sine of bx, then this height up here, this would be 3. So the scale changes, but the picture doesn't really. Now the period, so how far is it going to go? Well, that's going to be 2 pi divided by b. So sometimes we'll have something like, so for example, y is equal to the cosine of, let's change the amplitude here. So negative 5 times the cosine of x over 4. So here a is equal to negative 5, so the amplitude is equal to 5, right? Absolute value. And because b is equal to 1/4, notice we're dividing x by 4, so that's the same as multiplying x by 1/4. This means that the period is equal to 2 pi divided by b, so divided by 1/4. So that's going to be 8 pi, because when we divide by a fraction, we multiply by the reciprocal. So then graphing this, if I want to graph this, let's take this all to the other side. If I want to graph this here, we just want to graph one period. So on my y-axis, I'm going to have the amplitude. So up here, I'm going to have 5 and negative 5. And then on my x-axis, I'm going to have these 4 corners. Now, I want to graph this in such a way that these values, so 1, 2, 3, 4. So the period is going to end here, 8 pi. Well, this is half of that, so this would be 4 pi. And this is half of that, which would be 2 pi, and so in between here would be 6 pi. So this value just streams out. So for example, 0, well, here I get negative 5 times the cosine of 0. Cosine of 0 is 1, so I get negative 5. Notice this flips. It's going to go upside down now. Well, when x is 2 pi, I have 2 pi divided by 4, which is pi over 2. Cosine of pi over 2 is 0. At 4 pi, I get 4 pi divided by 4, which is pi. Well, cosine of pi is negative 1. Negative 1 times negative 5 is 5. And then we can keep doing this. So we can plug in these values into the function, but notice this graph looks very similar to what I did before. And I'm going to cheat a little bit and move this over there. So this looks just like I did before with the cosine function, except now it's flipped because this leading coefficient is negative. But the amplitude is 5. The graph looks the same, but yeah, we did change the x values as well, but we didn't change how this graph looks. So if we're going to graph one period, we can change our x-axis as opposed to changing the function. So that's just graphing sine functions. Next up, we're going to look at switching, so transformation, so shifting over to the left and to the right.